Okay, hello and welcome everybody. Today we're joined by Evan, who's going to present a DB AMA on Skeema. Evan, please take it away.
All right, thank you all for being here. My name is Evan Elias. I'm an independent software and database consultant based in the New York City area. And today I'm presenting Skeema. Skeema is an open source schema management utility. And what I mean by schema management is versioning, deploying schema changes. So not physically making online schema changes. This is not a tool to replace PTOSC or Ghost or those other tools. Instead, it's a layer above that to help you version your table definitions and database object definitions, allow you to have a process for engineers at your company to submit schema changes, have DBAs or other engineers review those changes, and then apply them across different environments and possibly different shards. So this is somewhat of a crowded space. There's a lot of prior art, both in terms of frameworks like Rails and Django that come with their own built-in way of managing schema changes. There's commercial tools such as Liquibase and Flyway. There's GUI tools like Shift. And there's a ton of different open source tools written in basically every programming language. So there's two main areas where Skeema differs from most of the other tools in this space. The first main one I would say is that it's built specifically for MySQL and MariaDB. So that applies not only to the features of the database, meaning like the data types and different table options. Many of the tools in this space are written to be generic and they kind of abstract different databases, but in the process of doing that, it becomes difficult or impossible to express features that only exist in one database. So this isn't a problem in Skeema because it's built specifically for MySQL and MariaDB. But it also extends to things like safety checks, like knowing which changes are potentially lossy of data and which ones are not. The configuration system of Skeema will be very familiar to you if you've ever had to configure a MySQL server or clients. And the ecosystem as well in terms of ability to use online schema change tools in the MySQL world, as well as sharding, which is very common at larger scale in MySQL. So I've personally been a MySQL user for 17 years now, hard to believe. And I've worked across many sizes of installations ranging from tiny startups to Facebook scale. So I definitely wouldn't say I've seen it all. I mean, there's just so many different ways to leverage MySQL. But I've certainly seen some things. And I've tried to incorporate as many lessons as I've learned over the years into Skeema so that it can give you good advice over what changes are safe, what features are better to use than others in your table definitions. So it is designed to scale. You can use it directly as like a full schema change solution. At smaller scale, you'd probably just be using the schema binary on its own. But at larger scale, you probably want to wrap it in some larger automation system or some other scripts. And it's designed to work both ways. Like it's designed to have clear exit codes, send certain output to standard out and certain other output to standard error. Basically designed to be built into a larger tool chain or automation system. So the other main difference between Skeema and most of the other tools in this space is that most of those tools are migration-based. So in a migration system, when an engineer wants to change a table, they create a new file called a migration, which either is just an alter statement on its own, or more commonly, it's using a domain-specific language to kind of convert an alter operation to Python or Ruby or some other language. So with migration systems, the changes are more imperative, like you are telling the database, like, make this change. Skeema, however, is declarative. So with Skeema, your repository is a collection of create statements. There are no alters expressed at any point. It's all just creates. So the idea is this is infrastructure as code. Your repo defines exactly the definitions that you want, like your ideal state. You have typically one definition per file. You can use a different layout if you want, but by default, this is what Skeema will use. And you just express creates, and then each directory has a config file, which I'll come back to in a little bit. So there are a lot of advantages to this approach, and it's a bit of a paradigm shift versus migration tools. So it's taken a little while for companies to kind of understand this, or for engineers to wrap their head around this if you've been using traditional migration tools. But the advantage to the declarative approach, your Skeema repo is a reference at any given time. Like, you can see what tables exist and what their definitions are without having to launch some other GUI tool that connects to your database, or without having to run commands in the terminal. You just have this repo that kind of represents the current state. And if someone else made changes and you need to update that, you just git pull. And you also have all the advantages of Git, in terms of your Git history and Git blame. So with a migration system, you have all these separate files defining individual little changes. They might each be adding a column or something like that. So if you want to figure out who added a particular column, you have to grep around to figure out which migration added it, and then like blame that or Git show that. With the declarative repo, though, you can just directly look at the history or the blame of any given .sql file. It's going to be a create statement, and you can see that very directly. You can also branch it. So if you might have some change that you're applying first to a staging environment, you might have some branch other than main or master that expresses the current state of your staging environment. And that works fine. And then when you're ready to apply that to your primary production environment, you can then merge that branch into your main or master branch. This also works really well for sharding. If you have a lot of shards, you will commonly hit this situation where you're rolling out some schema change across your environment, and you might have some master fail at an inopportune time. This was a really big problem at Facebook long ago, before I worked there. There was a lot of drift between shards that, they have so many masters and do so many schema changes all the time that they would have, some random shards would be missing certain changes. So Facebook developed an in-house declarative system to solve this, where the repo just expresses what state you want the tables to have, and then agents on each shard can just run in a loop, and eventually the change will succeed even after a master promotion. Additionally, this setup is really good in terms of rollbacks. So with a migration setup, typically engineers need to define both up and down migrations. Some tools do this automatically, others require the user to do it, which introduces possibility of user error. With a declarative system, this is just not a concept you need to worry about. Like, if you make some change, you later decide you need to undo that change, you can just do a git revert, or you can git check out a previous commit and then just deploy that. It's very cleanly mapping to the same deployment paradigms as software code. So those are the main differences, I would say. There are some core concepts to Skeema. I'm going to demo all this in a minute, but before I get into that, I wanted to just kind of dive into the config system and sort of the directory layout. So is this large enough for people to read?
Yeah, it's perfect.
Great. So here I have a very small Skeema repo. There's a parent directory, just called schemas, and then two subdirectories, each representing a different database. And in real life, depending on your company, you might just have one single directory representing all of your tables, or if you have a whole bunch of different databases, you would have a bunch of different directories. But the idea is each lowest level, like each leaf directory, represents a single logical schema. So that's a set of create statements that all go into the same database. Now that directory might end up getting mapped to multiple environments or possibly multiple shards within an environment, and those might be in different states at any given time. That's fine. The important concept is each of those leaf directories represents an ideal state, like a desired state that you want to deploy. So the config system exists to map these leaf directories onto actual databases. So there's these .schema config files, and those exist at different levels. So there's this one here at the top level of the repo, and then there's individual ones in the subdirectories. So these all stack. It's kind of like if you ever worked with Apache back in the day, the way htaccess files can be defined at different levels, and they all kind of cascade. It works like that. So anything that's in the higher level directory file will apply to subdirectories, but subdirectories can override those if you want. So here we're saying the top level directory here maps to a host just on my local machine here, and that's running MySQL 5.7. And this is defining it as the production environment. You can use any arbitrary name. The format of these is just like MySQL CNF files, with the main difference being that instead of having groups representing different programs like MySQL D and clients, things like that, instead they're defining environments. The default environment in Skeema is production, much like the default branch in Git traditionally has been master, although different hosts or different code providers are changing that to main. Any case. So here we are defining production server is at this location. We could define arbitrary other things here. We could also not have an environment, and then anything kind of above an environment line will just be global defaults that apply to every environment, and then individual environments can override that. So here in the product directory, again, this is saying that there's a logical schema named product. These are not in an environment, meaning that basically in any environment, we're saying the schema has the same name and has these character sets collation values. But you could use different values per environment if you wanted. It's totally flexible.
So different character sets per environment? That sounds like fun.
Yeah, you could do that. I have encountered some users who did that. They probably shouldn't, but yeah, you can do that.
I'm
there
sure
are a lot of different. Sorry?
in lints. I'm sure you get to in lints, but I'm curious before we get to that, if you can lint on changing the character set on a per table, per column, because I think that's like a bad thing to do.
Yeah, so I'll get to that a little more in linters, but you can define which character sets and collations to allow, and then define what to do if something is not using one of those, like whether it's a warning or an error, or you can set it to ignore if you just don't care. But that way, any given table level default or column that is using a different value, it'll tell you about that.
Okay, good to know.
But
Thanks.
you can't like whitelist certain things per table though. It's more of a global. So the lowest level you can configure right now is per leaf directory, like per logical schema. So you could have a different set of allowed character sets in one schema versus another. Like that is currently supported.
Yeah, I actually think it's an anti-feature that MySQL allows so much configuration there.
Yes, I could certainly see that being the case. Yeah, and MySQL is very flexible in some ways. That's great. In other ways, it's a lot of ways to shoot yourself in the foot. Okay, so that I would say is the core concept. You have these leaf directories, and you have configuration that allows you to map them onto physical database schemas existing somewhere. But the exact layout of your repo will depend on the layout of your databases. So at small scale, you might have just a single MySQL instance, but with different schemas representing environments. So you might have, your production database and development database are both physically in the same MySQL instance. Whereas at larger scale, you might have every developer has their own dev database, possibly on localhost or possibly somewhere else. You might have a staging layer, you might have production, which consists of many different database instances, possibly with different schemas or possibly with shards of the same logical schema. So the configuration system here is purposely designed to handle that difference. By default, it like out of the box, the init command might not match exactly what you want, but you can always edit the config files to match your actual layout. Another thing I'll mention quickly is that all the examples today are going to be on tables, which is the primary purpose of Skeema was created to manage tables and schema changes to tables. But it also supports stored procedures and functions. Those are actually things that I never used very much. Many companies that I worked for, shied away from putting functions and procedures in the database because the database is already kind of hard to scale. So there's certainly arguments against them, but there's many use cases where they make a lot of sense. And in the process of adding that support to the tool, I actually came to appreciate those features a lot more. And especially having a declarative way of deploying them and versioning them, it makes them a lot more powerful. So just wanted to mention you can do those. Skeema does not currently support managing views, triggers, or events. They certainly could be added someday. It's more a question of what the most users need. Views are probably the most common of those three. And when I say it can't manage them, it just basically ignores them. They can exist in your schema. It's just the tool will not interact with them or manage changes to them. And that can be helpful in some ways. Like you might have some triggers that are only there temporarily for PTOSC. So if that's the case, like Skeema just won't really know that they're there, which it may or may not be what you want. But so it's something to just be aware of. So I'm going to demo the core commands of Skeema now, starting with, gonna get rid of this for a second. I guess before I get into that, I should mention, so the Skeema command line tool, it's a free open source tool. It's written in Go, and as a result of being in Go, you get a native binary. There isn't a Windows native version yet, but you can run it under WSL, Windows Subsystem for Linux. I've heard that works pretty well. And there are native versions for Linux and Mac OS. So you can just download it from GitHub. It's also now on Mac ports. Sorry, not Mac ports, Homebrew. It's 2020. Yeah, so to use the tool and install, you just literally download it, put it in your path. So we'll assume you did that step. And if you want to get started using Skeema, the first command you use is init. And the options for this should be very familiar to you if you've ever used the MySQL command line client. It's basically the same thing. And you can tell it what directory to save to. It could be any name you want. If you don't specify that, it'll default to be based on the host name. But in this case, because I'm using an IP, that's probably not what we want. You can also supply username and password to this command. I have those already configured in a .my.cnf file, which Skeema will parse and use so that I don't have to get prompted for the password every time. And also on this command line here, I'm not specifying a database name. So that's one difference between Skeema init and the MySQL client. In the MySQL client, you can put a database name at the end. With the Skeema commands, not just init, but pretty much all of them, you specify the last parameter is the environment name. So it'll default to production if I don't specify anything. So there's a separate option if I want to just do one particular database. I can do that. I'm initially not going to do that. So what this is going to do, it's going to do a dump of the table definitions in this database. So I have this, Dockerized database running on my local machine with, two user level databases here. It's pretty much just matching the text files I was showing earlier. So there's just like a few tables in each of these. So what this is going to do is it connects to the database, it queries information schema, it also runs some show commands, and it's basically equivalent to running show create table on each table and then putting them each in their own file. So when I open this in my text editor, it's pretty much exactly what we were looking at earlier. Let me enable invisible files so we can see the config files. So by default, it'll populate these .schema files with, the parent directory is going to have the host information, and then the subdirectories have the database information. And then you can edit these files as you wish if you want to change your layout. So another option would be to only dump one particular database. So the way I ran this, dumping everything, that makes sense if you have like multiple distinct production databases in the same MySQL instance. If instead you have a setup where you only have one database, like one database schema in your instance, you could do it this way, although it's going to create that extra level of directory kind of unnecessarily. Or you could tell it you only want a particular schema. So I'm gonna wipe this out. And run this again. So this time telling it that I only want the product one, and just to show you the default naming, I'm not going to specify the directory to use. So now it dumped everything just to this single thing, and by default it named it 127.0.0.1 because I didn't specify a name. So when we look at this in my text editor, so we see there's only this one level of directory, and in the .schema file it created, it defines things for both the host level and the schema in the same place. And this is legal and totally flexible because the system doesn't really care what you put in each .schema file. The important thing is that once you get to the leaf directories, the ones that actually have these create statements, as long as the combination of the configuration from parent directories and the current directory defines both a host and a schema name, then the tool knows what to connect to, essentially. So now if, let's say that a change occurs from some other tool or some other user, and I want to update my my repository. Well, I guess I haven't made it into a repository yet, but you can run git init, and then I could push this to GitHub or somewhere else. And you don't have to use Git. You could use Mercurial or Subversion or something else as well. It's not strictly tied to Git. But anyway, so many companies have tooling that does this piece. Like even if you aren't using some larger migration or schema management tool, you might have something that dumps your definitions to a repo just so that that's a handy reference. And if you want, you could just use this piece of schema. And if someone, say, makes a change to the database by hand or outside of the schema tool, there's a pull command that allows you to update that. So let's say, well, first let me commit this. Let's help us in seeing history. So let's say, so got this, and this is like a fake blog setup, very minimal set of tables. So let's say someone manually changes a table. Now if I want to update my Skeema repo with changes from the live database, I can run the pull command. And what that says is the tool will go out and look at the database, whatever's defined by the environment I've specified in the directory I'm in. And it will look at the definitions and compare what's in the database to what's in the file system, and then update the file system. So it's sort of like doing an rsync type dump, like update to your dump. So here it detected that the posts definition changed, and then when I look here, this new column appears in my .sql file. When I look at the git status, I can actually see that the change that it has made. So this is kind of this is useful for sort of out-of-band changes, like some other tool or some other person updated something and you want to pull that into your schema definitions. It's also useful for a development process. So if you are using a framework like Rails or Django, those have very opinionated built-in ways of managing your data models and mapping those to table definitions. You could still use those in development. Actually run Rails or Django migrations in your dev database, and then pull those into your repo using schema pull, like schema pull development, or pointing it at your dev instance, and then go through a different process entirely for getting that to prod, like actually making a commit, making a pull request, and getting that reviewed, and then going through an online schema change tool, which you can configure schema to use.
Evan, I'm curious if it's still a workflow where you might, add indexes in production first to kind of get out of trouble and then pull them back. Is that something you see?
Yeah, I mean, from time to time. Certainly in an emergency situation, yeah, you might need to add something to production, and you might do it manually, especially something like adding an index, which in many cases in modern versions is not disruptive. So yes, you could do something manually to prod and then pull from production to update your repo afterwards. So now the meaty commands are to diff and push things. So this is the opposite direction of pull. So this is I want to actually make a schema change. So first, let me commit this change that I pulled. And really, you should have better commit messages than this, but for demo's sake. So let's say I want to add another column here, or maybe I want to index that foo column. And you don't have to format these strictly. There's a command to reformat it for you, and anytime you pull, it'll reformat by default. But you don't have to use back quotes and things like that if you don't actually have anything to escape. So I've added an index here, and if I want to see that, I can run schema diff. And what that does is it is saying, well, first, is this large enough everyone can read this? Okay. So this is saying, take the definitions that I have here in my repo, in the current directory, and look at the database this directory maps to, and compare the definitions between the two. So this is the core of the declarative approach. Is the tool figures out, how do I go from the state currently in the database to the state that the user wants, expressed by the repo. And what it's doing internally is it's introspecting a bunch of things in information schema and running a bunch of show commands and building an internal representation of tables. It sanity checks that its understanding of that representation is correct by ensuring that it can rebuild the create table in a way that exactly matches the show create table. And then, assuming everything's good, it then builds an alter. and it actually tests that alter in a temporary place. Like it'll create the before version of the table, an empty version of it, run the alter it generated, and then introspect the after version and confirm that that is matching what you've expressed in your repo. So there's a lot of safety mechanisms built in to make sure that it's not doing something wrong. So the output here, these info lines with timestamps, those are going to standard error. That's for human consumption. And then the lines without those prefixes are going to standard out. The Skeema diff command doesn't actually run the change, it just shows you what the change is. There's another command, Skeema push, that actually runs it. And there are entire deployments of Skeema that don't actually use push or don't use it directly. Because the idea here is because Skeema is built to be used in different pipelines and is built to send standard out, is basically always aimed to be legal SQL statements that you could, if you wanted to, copy and paste. Not that I recommend that, but more likely have some other tool consume. It works very well, as part of a larger tool chain. But if you're using it just directly, I can run Skeema push, and what this will do is connect to the database and actually run that alter. So very similar output to diff. Really, diff, it's the same code path. It's just running a dry run to push. So now if I run another diff, it should be an empty diff because it ran that change. So now, and same thing if I were to pull, all that's doing is rewriting this file because the format that I used wasn't the canonical format, but by default, pull will reformat things to match that. All right, so that's the basics of how you make changes. Everyone, any questions on that before I go further? All right. So that was a clean diff, a clean push. Basically, there weren't any problems with that. But Skeema has a set of linter rules built in. There's currently, I think, about a dozen of them. So different configurable things you can say, like if you have policies in your company where you don't allow certain column types, like companies that deal with money a lot might ban float columns because they're not precise. You might ban tables that don't have primary keys. Like that's a pretty common and good rule to have since they break a lot of things. Stuff like this. Ensuring that your changes are safe. These are things that traditionally a DBA would have to review and often repetitively inform different engineers at a large company that, like, yes, you need to have a primary key, or like, no, we don't use this particular column type, things like that. So the linters in Skeema are designed to eliminate that tedious step so that you might still have DBAs reviewing your changes, but they can focus on the actual important performance aspects rather than the sort of minutia of like little gotchas in MySQL that engineers might not be familiar with. So the linter also catches syntax errors. So let's say when I first typed this, I forgot to add that comma there. So if I were to try diffing this, it will immediately tell me. So what Skeema is doing internally, it doesn't actually have largely does not have an SQL parser. It only parses just enough to know what type of statement it is and what object name it is. But other than that, it doesn't contain an SQL parser. It relies on the database itself to be the parser. So it is actually running your definitions in a temporary place. You can configure where that temporary place is. But it actually runs them there so that this way, Skeema supports MySQL 5.5 through 8.0. It supports MariaDB 10.1 through 10.5. There's differences in the parsers in all these things, different features supported. Trying to map all of that in a tool on its own would be, kind of risky. Like there's a huge potential for drift between what your database actually supports and what a tool thinks it supports. So basically, Skeema sidesteps that entire problem space by using your database as the parser. So here, it's getting a literal syntax error from the database because there wasn't a comma there. But you can have actual like lint problems. Like let's say I don't have a primary key. I'll have to make this not auto increment also so it doesn't yell at me. And so now when I try to diff this, it'll generate the diff, like, you know, the diff in this case was getting rid of that auto increment and dropping the primary key. But it's warning me that this table doesn't have a primary key now. So diff and push will lint any changed definition. So if you're adding a new table, which in Skeema consists of just, you know, adding a new .sql file with a new create statement that doesn't, you know, that where there's no table in your target database yet. So whether you're adding a new table or changing an existing table, diff and push will lint anything that's been modified. There's also a separate Skeema lint command, which will just lint all of your definitions based on however they're defined in the repo. And these are configurable too. Like if you want to say that you really need everything to have a primary key, so you can say lint pk equals error. So now when I do a diff, it's telling me this is a fatal now. So warnings don't actually prevent push from proceeding, but errors do. So in this case, it wouldn't actually push any changes if I was to try to run Skeema push. And you can also, you know, there's several things that it checks that you might not care about. So you can also say ignore. So now when I run a diff, it doesn't tell me anything in terms of a linter error. So a related tool to this is the this sort of software as a service CI system that I built that integrates with GitHub. And that basically does a similar output to what you're seeing here in Skeema diff, except it runs it on your repo automatically and gives you inline comments. So I'm just going to demo that really quickly, not on this scratch repo, but on this other one I already cloned, because basically you need to configure the application to be tied to your GitHub repo. So that's already set up in this case. But let's say I want to make a change. Maybe I'll add a new table. So let's say foo.sql, create table foo. And that's it, that's fine. So I'm going to commit this. And so first, let me go to this on GitHub. So we've got some commits here. I'm going to push this commit I just made to GitHub. Refresh my list of commits here, and you'll see the commit showed up. This this yellow dot means that the linter check is running in the cloud automatically. And go view the details. This only takes typically around 15 seconds. So
the ignore PK thing.
Yeah, I'm trying that. I'm surprised that I guess, yeah, did I commit that by accident to this one?
I think you didn't add the file, maybe.
Oh, yeah, okay, that's what it was. I had a different, I already had a change there. Okay, fun time to demos. I'm gonna be bad and rewrite history. This is what happens when I have too many repos on my local machine here, just for demo purposes. All right, this time we should see this for real.
You need to see it was on purpose to see who was following, right?
All right, so it ran. Here we got the results. Found no errors and one warning. Because by default, the lack of a primary key is only a warning. So it's showing us here, on GitHub, in the GitHub interface, this annotation, and you can see it inline also in the commit. So with lack of a PK, it'll associate with the first line of a commit, but you can also, let's say I've got some type of typo. It's gonna misspell default. That. So what this is doing under the covers, it's taking the definitions and creating an ephemeral Docker container, matching the database version declared by the Skeema config, and running the definitions and comparing them to get the diff as well as to lint it. So here, because I misspelled default, it is getting that actual error from MySQL. And when we look at the commit itself, we see that inline on the correct line. Basically, it parses the line and offset information in order to figure out where to display this. Surprisingly, the most common mistake I see is people forgetting commas. Someone will add a new column and by hand and to their definition and forget to put a comma on the line before it. But yeah, regardless of what your problem is, like this helps find like little typos, things like that, as well as linting the changes. This also works with pull requests. So if you for a larger environment, the intended workflow is that an engineer wants to create a new table or change an existing table. They make a branch, add one or more commits to it, and then make a pull request, and then that gets reviewed either by a DBA team or by an engineering team, depending on the process your company uses. One of the main purposes of this tool is to give you these configurable linter guardrails so that if you want to have self-service schema changes where individual engineering teams are kind of responsible for their own tables, this can help you set up that kind of workflow. And then that kind of offloads a big chunk of tedious work from a database team, which can focus more on like the core product tables and then performance things and the infinite number of other things that the database team has to do. This way, they're not always just kind of checking for typos and things that have duplicate indexes and things like that. So that's the CI product, which I'm rebranding as the Skeema Cloud Linter. The notion of database CI hasn't necessarily resonated with everyone as clear as to what it is. So that's been in beta for a while. It's going to be finally coming out of beta later this month.
That's really cool.
Thank you. So another aspect of diff is the notion of unsafe changes. So if you are doing something that destroys data, whether that is dropping a column or changing the type of a column in a way that is lossy, or dropping an entire table, these will all get flagged as being unsafe. So let me go back to my other, the repo I just set up here. So, I added that foo column to the post table. Let's say I get rid of that. Now I run a diff. Let me bring back the primary key also. And that way we're not going to have the warnings about that. Oh yeah, I guess I need to get rid of the index on that column I got rid of as well. So now when I run a diff, it's by default, it's telling me that I'm trying to drop a column. That's not really safe unless you know what you're doing. So by default, it will block it. And it will block it even in diff, even though diff doesn't actually run the changes. this ties into the notion of diff and push being the same code path. So you can get by that in diff or push by saying allow, can't type today, allow unsafe.
10-minute warning.
So now it's showing me the diff and it's not blocking on that error. Because the change in this case was to drop the column foo, add that, I guess, oh yeah, because I never pushed that previous change, dropping the primary key, but I did have it drop the auto increment. That's why this is showing up. And then dropping that index. So typically you want to be real careful about unsafe changes. You could configure allow unsafe equals true or 1 in the config file and always allow this, but I strongly recommend against that because you're going to shoot yourself in the foot eventually. This also applies to dropping tables. Like if you want to get rid of an entire table, you can remove the file. So I dropped comments.sql. There's now no definition of the comments table. There's no create table, mapping to that. So when it's comparing what's in the repo to what's on the database, it sees that doesn't exist anymore. So you want to drop, but by default, it will catch that. There's also this other option, safe below size. So if you want to say that you want to allow unsafe operations to empty tables, or you want to allow unsafe operations to tables that are of a trivially small size, you can use this option to do that. You can say safe below size equals 1M for 1 meg. As a special case, you can say safe below size equals 1, and that will allow changes to empty tables. But even though empty tables take up a tiny bit of space on disk, Skeema as a special case will consider them to be 0 size for the purposes of this option. Yeah, the other cool thing with this is you can define it just for one environment. So you could say in dev, always allow unsafe or allow safe things below a certain size, but in prod, you can skip those options. One last thing I'll demo before opening it for questions is use of online schema change tools. So by default, Skeema won't do online schema changes other than whatever MySQL does by default. So I believe in modern versions, it will always do the most concurrent version of an alter. So like, MySQL will use its internal online DDL if the operation supports it. So Skeema will basically be doing that. You can configure that through options if you want to use online DDL and bail out if it's not supported for that operation. There are options to do that. More likely though, at scale, you're going to use some external tool like PTOSC. So I have another one already set up here. Just the config, you only have to configure this once, but it takes a minute to configure. So this here. So the way you configure online DDL is through the alter wrapper option. And it supports a templated command line. So here we're saying for all alters in production, instead of just running the DDL directly, use PT online schema change, and then pass it the correct set of clauses for the alter statement itself, and then supply all the connection info that's already configured in Skeema, just pass that on through. And the X here means when displaying this, don't actually output the password. It'll still use the correct password internally, it just won't display that standard out. So here, if I want to make a change to a table, let's say I'm adding something here to the users table. Now when I run a diff, okay, so before I do this, I should reset the state. So these are both pointing at my same local demo database. That's why we're getting kind of extra changes here. So get rid of that. What I'm doing here, I'm just reverting back to a clean state here. Oh, I still have that typo in there as well. So now I'm back to a clean slate here. Gonna try this demo again. Git check out my branch that already had PTOSC set up. Confirm that there's no differences. Good. Okay. Adding a column to my users table. Now when I run a diff, so again, diff doesn't actually run the change. So it's not actually running a PTOSC, it's just showing me what the command line would look like. And it's prefixed with !! This is the shortcut for running system commands from the MySQL client. Again, this goes with the notion of the ability to either copy and paste standard out into MySQL client or interpret it from another tool. In that case, if you have a pipeline, you'd have to look for this specific prefix, but you could still parse these things out and execute them. So now if I actually go and Skeema push, hopefully I have PTOSC correctly working on my Mac. It can be a bit challenging, but I believe this should work. Yep, so that went, it actually ran PTOSC on this table with this alter, adding a column. Since the table had like few or no rows, it was very fast. In real life, this would take quite a bit longer on a large table. And now if I run a diff again, it should show no changes. Yep. Cool, so that's the basics. Going through it very quickly. There's some other commands, again, I mentioned Skeema lint. That will lint all the definitions and reformat them. Not just the things that have changed. And then if you only want to reformat, there's Skeema format. That's not going to do anything right now because lint already just reformatted this. But those are the basic commands. So wow, almost used all the time, but happy to open it up to questions. And if you don't want your question on video, we're going to do non-video recorded questions in a couple minutes.
Awesome. Thank you, Heaven. I have some questions, but I want to let others go first, just in case there are others that want questions. Otherwise, it'll take up all your time. You want me to jump in?
I think you should go for it, Morgan.
Okay.
I have a question. I have a question before Morgan then.
Okay.
So if you, because you are doing a like kind of environments, right? You can define all your environments. If you decide, for example, that you have an environment where you have developers, staging, and productions, but different kind of production maybe, and the developers, they have like one application that needs different version of the schema. Can you do it, or you need always to branch with the version you need?
Different version, meaning you have things in one environment that are permanently only in that environment and not in other environments?
Yeah, for example, let's say you have an application. The application, it's Morgan app, and you have Morgan app v3 in development, Morgan app v2 in staging, and in production, you have already one customer using Morgan app v1 still, and Morgan app v2. And if you want to deal with the schema changes there, and at a certain point move, forward all of them, can you do that, or you need to have branches?
Currently, if there are things that are permanently different between those deployments, like so, there's not one single common logical schema that maps identically to the desired state that you want. Yeah, currently you'd have to have different Git branches. In the future, I'm going to add support for a notion of additive-only changes where it won't generate any drops or anything destructive. It just ignores generation of that, so that if you're trying to just add a column only and don't care about other differences, you'll be able to do that. But yeah, currently, to do that workflow, you would need to have some sort of Git branching structure that reflects that.
Okay, thank you.
Okay. I'm fascinated by linches. Like, I'm curious what other linches you have. If you could use linches to, prevent using certain data types for MySQL DB compatibility, things like that.
Sure. So currently there's, I think, about a dozen of them. Some of them, so for each of these options, this affects both the schema lint as well as schema diff and schema push commands. And each of these lint options you can set, they're all enums. You can either set to ignore, warning, or error. And because Schema supports configuration very similar to MySQL, you can also use a skip prefix on any option to negate it. And in the case of the lint options, that just is the same as setting ignore. So some of these you just set on their own, like lint has float, for example. If you set that to warning or error, it'll flag any float or double column. There's not really any more configuration to it. Other ones have companion options. So like lint engine, there's this companion option, allow engine, which specifies the list of storage engines you want to allow. And then any storage engine that's not in that list that it finds, it will give a warning or error depending what you've configured to. So in the case of allow engine, it's just a free-form list. By default, it will only allow InnoDB, but you can add other ones. It's just a comma-separated list. So the different ones it supports, you can configure what column types to allow for auto increments. By default, the allow list for that will not include signed values, since unsigned technically is or a signed value is technically negative numbers. Technically, according to the manual for MySQL, are not. They're supported for auto increments, but the behavior is not really well defined. So you could configure this to only allow big ints if you have a very large environment. You can specify what character sets to allow. There's a lint character set option. Compression options, this is a new one. This work was just sponsored by Etsy. I'm very, very happy that they sponsored that. So you can configure which key block sizes to allow. You can also use this to allow page compression, which is not enabled by default because it depends on the file system and other setup. If you're using stored procedures, there's a couple linter options around those in terms of their definers, if you only want to allow certain proc definers, for example. So there's other linter options around display widths. This one will warn you by default if it's a non-standard display width. I think, Morgan, you might have actually given me the idea for this. I'm trying to remember. I know there was a lot of feedback from people in Slack a while back. So
I can remember.
So yeah, this one, display widths are commonly misunderstood. They've actually been deprecated and removed from the very latest 8.0 releases. Because they don't do what engineers think they do typically. For ints, they typically don't do much of anything. So if you use a non-default one, it'll warn you that it's probably not doing what you think it's doing, unless it's a Boolean, in which case it'll allow that. Duplicate indexes. This is a really important one. Often, random software engineers might not understand the left to right behavior of indexes and will inadvertently introduce duplicate ones. Use of foreign keys, many environments don't allow them. So by default, this one is off, but you can set it to warning or error if you don't allow foreign keys. Schema does support foreign keys. There's some caveats, but mostly they should work as intended, but then your OSC tool of choice might not allow them. Let's see, floats we talked about. If you don't want to allow stored procedures or functions at all, you can warn on those or error on them. Time-related types, some companies don't like the time zone behavior of them or the automatic timestamp behavior, which has gotten a little more sane in recent versions of MySQL. But
basically, you might be worried about Y2K with timestamp as well.
Yeah.
Yeah. Coming there, Evan. I think we're out of time, so I want to thank you for coming, and I'm going to stop the recording so that people don't feel bad if they have to leave.
Yeah, thank you all for coming. It's been my pleasure.
It's been amazing. Thank you.